Hi, welcome to the tutorial for HO5. To find the tutorial, we'll go back onto the OSeMOSYS page like previously. Click on course content, we scroll down to lecture 6, where we find hands-on 5. This again is the PDF with the instructions. So the learning outcomes of this hands-on is to define an existing thermal power plant taking in fuel to generate electricity, define the existing transmission network, define the existing distribution network, and run the model and check results on production by technology and capacity of each technology. So, make sure you read through this hands-on. After you've read through this bit, we will proceed to define an existing thermal power plant taking in fuel to generate electricity. For that, to define such a power plant, we need to define it in terms of the input activity ratio, output activity ratio, capacity to activity unit, and the fixed cost. There is also the capital cost, operational life, residual capacity, and capacity factors that need to be defined. So, let's try and define power call. Before we do so, like previously, first things first, we go to local disk C, OSeMOSYS and FlexTool, HO4, copy the previous SAND interface, we go back to OSeMOSYS and FlexTool. Here we create another folder and we call it HO5. We paste the SAND interface over here and we rename it to HO5. Afterwards, we open the SAND interface. Whilst this is opening, we will need the data prep file in order to import the data. So, right click and open in a new tab. Once the link opens in a new tab, we scroll down and we download data prep for hands-on. We open this as well. So, following the instructions, we enable editing in both of the files and we go to the SAND interface. Following the instructions, we go to Sets, and the first thing we do is in cell B10, we change TEC 007 to PWRCOA. And in the description, we add coal power plant. Following the instructions, what we need to do is in cell E7, we need to add ELC001. And the description for this will be electricity from power plants. Why we've added this, refer to the lectures and to the hands-on to understand. Once we've done so, we go to the parameter sheet. We make sure that in the parameter section everything is selected, and in technology we choose power coal and we tick off import natural gas or whatever it was that you were defining before. So, as it is stated in the hands-on, we'll need to add the input activity ratio, output activity ratio, capacity to activity unit, capital cost and fixed cost, operational life, residual capacity, and capacity factors. We do this one by one by following the data that is given in the data prep. So, in the data prep, we choose the sheet that says power call. We can zoom out a bit to make it easier for us. Scroll to the left. We go to the top of the page. And we begin the input. So the first thing we input is the capacity factor. We copy this, so Control C. Then we go onto the sound interface, where we also scroll to the top of the page. And for capacity factor, in cell K933, right click, paste values. Then we select this and we drag it until the last cell that says capacity factor, which is cell 1028, so 1028. Once we've done so, Control C, Control Shift right arrow, and Control V. So this sets the model so that throughout all the period, the capacity factor of the thermal power plant is 85%, to be precise. So we go back to the data prep file. Scroll down. Here we see that the capacity to activity unit is set at 31.536. We copy this and we go to the sound interface. Where we find the capacity to activity unit, and we paste this by right-clicking and selecting paste value. In the data prep file, capital cost has been defined as 2,500. When copying rows for capital cost, fixed costs, please copy the whole row. So what I mean is Control Shift right arrow and then Control C. This is because the capital cost and the fixed cost could vary for some technologies. So we come back over here, we go on capital cost, right click, paste its values. We go back to the data prep file, scroll to the left. Here we see fixed cost. We copy fixed cost in the same manner, so Control Shift right arrow, Control C. We go to the sound interface, we find fixed cost, right click, values. Go back to the data prep file, scroll to the left, and here we see that the input activity ratio is 2.7. This we copy in the same manner, so Control Shift right arrow, Control C. Then we go to the sound interface. So we were defining call, so it's the input activity ratio for call. Right click, paste these values. We go back to the data prep file and scroll to the left. So now we scroll down. And here we see that operational life is set to 35 years. So we go onto the sound interface, we scroll down until we find operational life, and we change this to 35. The output activity ratio has been defined as 1 for ELC001. So we copy this, and keep in mind ELC001 refers to electricity from power plants, the one that we just defined. Go to call. No, we go to ELC001, apologies. We put this as 1. Control C, Control Shift right arrow, Control V. This defines it for the whole period again. So if we go back onto the data prep file, we scroll down, we see that total annual max capacity, no, apologies, residual capacity is set as 0. We check to see if this is the same over here. And it is the same. For the sake of consistency with the data prep files, we copy this big number again. So now we copy this for the whole row. So Control C, Control Shift right arrow, Control V, Control C, go down, Control V, Control V, and over here, Control C and Control V over here. We check the variable cost, which is set at 0. So we set this at 0 as well. 0. Control C, Control Shift right arrow, Control V. Control S to save this. So now we go back onto the hands-on and we scroll down. Now, as I said, we saw that the residual capacity was 0. So this is because it was assumed that in this ideal region there is no existing coal power plants installed before. So watch out, this is not true for oil power plant technologies, which will be added next. Proceed in the same manner to add the light fuel oil power plant, gas power plant, and the CCG, and another gas power plant. Use the data in the data prep file in the different sheets. So as you can see here. Once you've added those, we need to define the existing transmission network. To define the existing transmission network, we need to input the input activity ratio, output activity ratio, capacity to activity unit, fixed cost, capital cost, operational life, and residual capacity. So to do so, what we do firstly is we need to add power transmission. We go onto the SAND, set, and in cell B14, we add PWRTRN. And in the description, we add electricity transmission. Please read the description provided on the hands-on to understand what is the difference between ELC01 and ELC002 for electricity after transmission. So now we need to add electricity after transmission in cell E8. So we go to SAND, we select cell E8, we type in ELC002, and we write over here electricity after transmission. Next, we go into the parameter sheet, scroll to the left, in technologies, we deselect power coal, or whatever you were defining before, and we select power transmission. Then we go to the data prep file, click on the right arrow over here until we find power transmission, and we'll copy and paste the values just as before. So let's start from the top. Capacity factor is 1, which is already like that in the SAND interface. So we scroll down. Capacity to activity unit is 31.536. So we copy this, go into the SAND, scroll up, Here we find the capacity to activity unit. So we right click and paste it as values. We go back into the data prep. Capital cost. Remember, we copy this by doing Control Shift right arrow and then Control C. We go back onto the sound interface, and in capital cost, we right click, paste as values. We go back over here. We check the values over here, which are all 0 except for ELC001. So we copy this, Control Shift right arrow, Control C. Go into the sound interface, find ELC001, right click, paste as values. We go back to the left over here. We scroll down. Operational life is set as 50, so we change this in the sound interface. Scroll down. Go back to the data prep file, and we see over here that at ELC002 the value is 1 for the whole period. So Control Shift right arrow, Control C, ELC001, right click, paste as values. Go back to the data prep file, go back to the left. We scroll down, and we see that the residual capacity has been defined. When copying residual capacity, also copy it the whole row. So Control Shift right arrow, Control C. As you can see here, for the last years, the residual capacity is 0. So this is why you need to copy it like that. We scroll down on the sound interface, find residual capacity, right arrow, right click, paste as values. Again, for the sake of consistency with the data prep file, we copy the big number, Control C, Control Shift right arrow, Control V, Control C, go down, Control V, Control V. We check the data prep file. We see here that variable cost is at 0. So we change this to 0. And we also keep the big number over here. Control S to save this. We go back onto the hands-on and we scroll down. Now we need to define this existing distribution network. So what we do is we go into the sound interface, set in cell B15, we write PWRDIST, next to which we write electricity distribution. Now, we don't need to define another commodity over here, as electricity after distribution has been defined before. What we do is we go back to the parameters, technology, scroll down, unselect power transmission, and select power distribution. Click OK. Now, for the power distribution, we need to paste the input activity ratio, output activity ratio, capacity to activity unit, capital cost, fixed cost, operational life, and residual capacity. So we do so followingly. We go to the data prep file, we go to sheet 15, where it's the power distribution, scroll down until we find the capacity to activity unit. Apologies for that. Here, capacity to activity unit is 31.536. If you want to know why it's 31.536, please refer to the lectures, which will give you an explanation. So we copy that number, we go into the sound interface, we scroll up until we find capacity to activity unit, and we paste it as a value. Back to the data prep, capital cost, Control Shift right arrow, Control C, back to sand, capital cost, right click, paste as values. Back to the data prep file. Here we see that fixed cost is defined as 0. We check with the sound interface, which is also defined as 0. Then we see ELC002, which you can see changes, so we copy the whole row. This is for the input activity ratio. So we go into the sound interface, ELC002, and we right click and paste as values. Go back to the data prep, scroll down. The operational life is 70, so we go to the sound interface and change this to 70. There we go. We go back onto the data prep, and we see that for ELC003, the output activity ratio is 1. So Control Shift right arrow, Control C, sound interface, ELC003, right click, paste as values. Go back to the data prep, go to the left, scroll down, residual capacity, so Control Shift right arrow, Control C, back to the sound interface, scroll down, find residual capacity, right click, paste as values. Once more, for the sake of consistency, we're going to copy the big number. So we paste it, Control C, Control Shift right arrow, Control V, Control C, we go down, Control V, down, 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 Control V, and we check the variable cost, which in the data prep file is 0. So we set this as 0. And we also copy the big number over here. Then we Control S. Once we've done so, we'll go back to the hands-on. So now we need to run the model and check the results on production by technology and capacity of each technology. So to run the model, what we need to do is the following. Firstly, we close data prep, sound interface. So at this point, I have not defined all of the technologies that we had to define. I've only defined coal power plants. Make sure that you define the oil power plants and the gas power plants. After you've done so, what you do is you close your Excel file, minimize this, You go to local disk C, program files, click send. Essentially, I'm repeating the same steps that I've shown you in hands-on 3, where we had to run the file, where we had to run the model. So export templates, this PC, local disk C, OSeMOSYS and FlexTool, H05, okay. Templates exported. So we go back to H05. We delete the unnecessary sound interface, come back onto click send. For data source, we select in folder H05 the sound interface, open, and then for the code we select OSeMOSYS code using the 3 arrows over here just like before, the 3 dots over here just like before, and then we're going to click on run. So this is going to take longer to run than your previous model. Please be advised for it. Once the model has finished running, you will get the following screen. So what we need to do is follow the same steps as in hands-on 3 to visualize the results. We come here and we find sound interface results, rename H05 underscore results, results database, enable content, right click on macro, run, we copy the results path, /H05 underscore results .txt. Always remember to write .txt. Click OK. Yes. 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 Then we go back onto here, onto the folder of H05. We open results template, enable content. We go to annual electricity production. Let's go to the left. We select cell A4, pivot table analyze, change data source, choose connection, browse for more, H05, results database, open. Okay, 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 and we click OK. So again, you get a blank graph. What we do is we come into column labels. Here we deselect mean coal, we scroll down, and we select power coal, power natural gas 001, power natural gas 002, and power oil, and we click OK. You should get the following graph. Once you've done this, you've completed H05. Thank you for watching.